Let's continue on with solving an equation. This time we're going to talk about a logarithmic equation. And a logarithmic equation is an equation that contains a variable in a logarithmic expression. Here's an example right here. This equation has a logarithmic expression. Here's the log base 4x plus 3 equals 2. Here's another logarithmic equation. Here we have the natural log, and then the natural log here. So there's 4 steps to solving a logarithmic equation. The first one is we're going to express the equation in the form of log base b m equals c. Sometimes this will be already done for you, and sometimes it won't. Then we're going to use the definition of a logarithm to rewrite the equation in exponential form. So log base b m equals c means you have the base of b to the c equals m. Remember, this is your base, this is your exponent, and that's what it's equal to. Then we're going to solve for the variable. And then you're going to check solution. In original equation. Okay, so we're going to check solution in the original equation. This is very important. It's not really optional. You have to go back to when we graph logarithms, and here's the sketch. Remember we graphed logarithms before, and there's an example of a logarithm. Remember we said that the domain of a logarithm was from 0 to infinity. So we gotta be real careful when solving logarithms. The x value has to be between 0 and infinity. It can't be 0, and it can't be negative. So can't take a logarithm of a negative number or 0. Okay. Go back to that little idea of when you graph logarithms, remember that the domain, we had that little asymptote right here. And we said that the x value could not be 0, it would never reach 0, but it would be close to 0. And we never had to really check in our exponential equations because x could be anything in those. Okay. Let's go ahead and do part A in example 6. Solve this logarithmic equation. And the first thing you want to do is you want to make sure it's in the form of, different color here, in the form of log base b m equals c. Okay, so we have that right here. We have log, we have a base, and we have m equals c. So the first thing we're going to do in part A is we're going to go ahead and rewrite this using the exponential form. So it can be 4 to the second power is going to equal x plus 3. So when 16 equals x plus 3, I subtract 3 from both sides. I get 13 equals x. Now we're going to check it. I put 13 into here. I get log base 4 of 13 plus 3. Does that equal 2? Is log base 4 of 16 equal 2? And the answer is yes. 4 to the second power equals 16. So 4 to the second power equals 16. Yes. It does check is the answer. In part B, I have the equation 3 natural log of 2x equals 12. Again, we want this in the format of logarithm, so we want it in that form. But right now, we want to have log, we want the natural log, and we don't want a number in front of here, a coefficient. So I need to get rid of this 3 right here. Okay, so I'm going to go ahead and divide both sides by 3. So I get natural log of 2x equals 4. And now I have that in logarithmic form. So the base here is e. So e to the 4th power is going to equal the 2x. Now if I divide both sides by 2, I'll get x alone. Okay, so that's the exact value. This is the exact value. Okay, and then the approximate answer is going to be, when I divide that out, so I get e to the 4th power. I'm going to divide that by 2, and I get approximately 27.30. If I want to check it, I would check it up into here. So I would do 3 natural log of 2 times 27.3. That should be equal to 12. My calculator gives me around 12. Okay, that's the right answer. So here's the exact and the exact and the approximate answer. In my math lab, it's probably going to ask you for the exact answer, but on the test or the exam, I want both those answers, most likely, to make sure you read the directions. Okay, so go ahead and pause your video and then try these two on your own, and then replay the video and check your answers against my answers. Okay, so part A, I got x equal 12, and when I checked it in there, I got a true statement. That's the correct answer right here. Part B, when I solved it, I got x equals e squared over 3, x is approximate 2.46. And in the last example, I forgot to go ahead and show the check. I did the check on the calculator, but I want to show it on the test, especially because I don't know if you checked it unless you show me. You want to show this check. And let me go ahead and do that here. So I'm going to do 4 natural log of 3 times 2.46. Did that equal 8? So I type in my calculator, type in 4 natural log of 3 times 2.46. I get 7.995, which is approximately equal to 8. So that means this is true. This is the right answer. And I just typed that straight in my calculator. I didn't have to use the definition at all. Here I use the definition because it's with base 2. With base 10, I just type my calculator. Here, natural log, my calculator would do that. So I'll go back to the last example. If I check this, I would have shown 3 natural log of 2 times 27.30 that equal 12. If I do that, I get 3 natural log of 2 times 27.30. I get 12.0001 equal to 12. That does check. Okay, that one does check, and this one checks also. Let's go to example 7. And with example 7, you're going to notice that there's 2 logarithms here. And we want to make sure that we have our logarithm, if we can, in the form of this right here. Okay, log of base m equals c. We have 2 logs. Is there some way to condense this, make this one log? We'll go back to the product rule back in the last section, and we can combine these two into one log. This is log base 2, and this is actually a sum of 2 logs, same base. Same thing as x times x minus 7 equals 3. You don't have to have these brackets here, but this entire product, we can put these two to the product and keep the same base. So now that we have that, now we have one single logarithm. So now we can just say 2 to the 3rd power equals x times x minus 7. So 8 equals x squared minus 7x. Second degree equation, so I'm going to set one side equals 0. So minus 8 from both sides. So I get 0 equals x squared minus 7x minus 8. I'm going to factor this. Hopefully it does factor. And I do negative 8 plus 1. I think that works. x squared. This gives you positive x, negative 8x, which gives you negative 7x. This gives you negative 8. That means x must equal 8 or negative 1. Okay. Now we got to check both the solutions. We got two solutions. They're going to check them both. They're going to check. I thought check wrong. Check. Doing blue here. We're going to check x equals 8. Then put in the original equation, log base 2, 8 plus log base 2, 8 minus 7. Does that equal 3? Well, this right here is 3. 2 to what power equals 8 is 3. And here I have log base 2, and 8 minus 7 is 1. Okay, and right here, 2 to what exponent equals 1, or 2 to 0. That would be 3 plus 0 equals 3, and that would be true. That means this one is correct. Now check the other one. Check x equals negative 1. The log base 2 of negative 1 plus log base 2 of negative 1. I'm running out of space here. So we have negative 1 plus 7. Does that equal 3? Well, you can't take a logarithm of a negative number. Talk about that earlier on. You can't take log of a negative number. So, like if you look back here, remember we talked about logarithm graph, and we said the domain x can only be from 0 to infinity, so you can't have negative x values. We talked about the graph of the logarithmic function. So because of that, then we know that x equals negative 1 is not the answer. This is the only solution I have there. Okay, so go ahead and pause your video and try the next one on your own. And then make sure you show your check for both solutions. You're going to get two solutions and check them both. Sometimes they both work. Do that in the test where sometimes they both work, sometimes none of them work, and sometimes only one of them works. So make sure you check them both. Go ahead and pause your video. Okay, so the on your own problem, I want to condense this. They both have base 10 here. It's not written, but we assume it's base 10 because there's no base written. And I want to do the product. We're going to combine them. We got log base 10 x times x minus 3 equals 1. And I know that 10 to the first power is going to equal this. So I went ahead and set a secondary equation. And I solved. I got x equals 5 or x equals negative 2. Now I'm going to check this. There's two ways to check this. When I put in the 5, I get this statement here. Since this is base 10, you could just type this in your calculator. So you could just type in log 5 plus the log of 5, I'm going to close that parenthesis, plus the log of, I'm going to type in just 2, because 5 minus 3 is 2. My calculator will give me 1. Or if you don't want to use your calculator, you could just say log base 5 plus the log of base 2, or log of 5, not log base 5, my bad. The log of 5 plus the log of 2 equals 1, question mark, it would be log, and if I use the product rule, that would be log, it would be 2 times 5, which is 10, equals 1. Well, 10 to the first power is 10, but I could just type it in my calculator. That would be perfectly fine. Now if I check x equals negative 2, I get log of negative 2 plus the log of negative 2 minus 3. Does that equal 1? Well, you can't take logarithm of a negative number. Okay, so I'm getting ready to run out of time, about 40 seconds left, and I want to show you, some students will think that if you have a negative number, it automatically doesn't work. In this case, this one doesn't work, but you can have a negative value as one solution. So I'm going to show you an example in the next video of you can have a negative answer, just can't have a negative logarithm. Okay, so go ahead and stop the video, and I'll start that in the next video.